All right, starting. So there are two types of distributions in 4.3. One is called geometric distributions, and one is called Poisson distributions, like a French word, Poisson. And these ones are the Poisson distributions are not on the AP test, and we're not going to go over them. We might go over them because they might come up, and I think a few of you are actually planning on going into stats. So it might come up for you later, but we'll do it maybe after the AP test and not before, that's for sure. Okay, so we've already done binomial experiments, and now this is geometric. A geometric experiment satisfies these conditions. Instead of a set number of trials, a trial is repeated until you get a success. The repeated trials must be independent of each other. Probability of success is the same for each one. Which of course means the probability of failure also stays the same. So again, it's a yes or no kind of failure situation. And then finally, the random variable x. Represents when the first success occurs. So just like before, P is the probability of success. Q is the probability of failure. And X is the numbered trial when the first success occurs. All right, so example number 1. LeBron James, his free throw record, or I guess chance of success was 75%. So he made his free throws 75% of the time. And we have to find the probability that the first free throw shot he makes occurs on the 3rd or 4th attempt. What do you think? Is that good chances or bad chances that that would happen? The first success he has. What do you think? Low, yes, because if he makes it 75% of the time, you would think he's probably going to make his first shot, right? And if he doesn't make his first shot, he's probably going to make his second shot. So the chances that the first success would happen on the 3rd or the 4th one is probably going to be fairly low. So if we get like a 90% chance or something, we know we're wrong. That makes sense? Okay, so anybody, and I am going to give away a pen for this, think they can come up with a geometric probability formula. It's kind of similar to the binomial probability formula. Remember, you got to fail a whole bunch until you succeed. So the probability of x is. Anybody want to give it a shot? Come on, be brave. Mason, you want to do it again? Everybody's going to let Mason have 2 pens? All right, Mason.
Would you do 0.75?
Right, but we're doing a general formula, but we can do it up here too.
Oh,
So, all right, probability of the third one would be 0.75 to the what?
would it be maybe like the fourth or the third? Or?
Well, we want him to succeed how many times? And this is the chances that he succeeds on his third try, right? So how many times would he succeed?
On his third try?
Yeah, on his third try he succeeds, right? But what happens on his first and his second try?
He
He what?
was missing
He was missing. Okay, so how many successes does he have then?
on the third try.
On the third try?
One.
One success. And how many failures did he have? 2 failures. Now, when we were doing binomial probabilities, we had to like figure out like where were the wins, right? Where were the losses? But we don't really need to figure this out this time. Do you know why? When is his success going to happen in a geometric probability? The what?
Something.
It can't be the sometime, some point. Like specifically for probability of 3, his success happens on the third time. Okay? And it's always the last time, whatever it is, because after that you just stop playing. So you don't do this anymore. You go until you succeed, and then you write down how long it took you to succeed. So there's no reason to figure out, like, where did this success happen, because we know it was the last thing that happened. Okay, so go for it again, Mason. Tell me this one.
So it would be 0.75 to the 1.
Mm-hmm. Yep.
And then 0.25 to the third.
Okay, all right. Can you do this? Can you tell me what's the probability of x? In general.
Would it be P
Yep.
it'll be 1 every time.
It's 1 every time. You can put a 1 there if you want to, or you can just leave it as p.
And then it'd be times Q to X minus
X minus how many times you succeeded, which is how many?
1.
That is exactly right. That's the formula for geometric distribution. Mason, you are just rolling in pens. You're not even using one today, because you are one of those people that like doing math with pencils. All right.
I do use them though.
You do use that. Which classes?
They're 9 and 7 and sometimes.
What's your going to study?
I'm getting my CNA. So I'm
Nice.
doing that online. Just kind of, I have a whole block where I just do online classes for that.
Beautiful. Would you like a different color to organize your notes?
Yes.
Not that you would ever need to have notes during nursing. Definitely not. Not that they have like a whole bunch of stuff that they have to constantly remember. I thought going to school for like being a teacher was bad because I had to take so many math classes, like 16 math classes in college. And some of them were enjoyable and a lot of them weren't because they were really, really intense, hard math classes. And I would never want to go to college to be a doctor. Like I can't imagine the amount of memorization that happens and that kind of thing. Okay, now if you're finding, do you guys remember what it means when it's an or problem with probability?
Is that the one where like you take this plus this minus this?
Yes, this plus this minus this, and it's the first thing plus the second thing minus the overlap. What's the probability